Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello students, welcome again to the TV learning programs. I'm Teacher Pasco, and today I will be with Senior 1 students continuing with unit number 5, atoms, elements and compounds. But today we will have a new lesson. We have seen that matter is composed by atoms. You remember that. We have seen what we call an element. But if we consider atoms, elements, and matter itself, we know that matter is a combination of various atoms. So today, what we will look at is one kind of a chemical combination of atoms that we call radicals. So today's lesson is the radicals. And before we dive deep in our lessons of today, let us read the objectives. At the end of this lesson, you should be able to define a radical and explain why it forms. Why do radicals form? Or why do atoms combine? So you should be able to explain that in brief. And number 2, you should be able to write the formula of various radicals. Just like how we used to write the symbols of elements, you should also be able to represent symbolically the radicals and name them. And number 3, we should be able to write formula of some common ions and name them. So we will also have a look at what we call ions. Here we have a revision question. We have one question with 2 sub-questions. What is meant by the terms an element and a compound? I give you 1 minute to work on those 2 terms. You define them. I hope you have your notebook and a pen, of course. So let me give you like 45 seconds or 1 minute, and you try them. We have already covered this content in the previous lessons, so I think it's not something very difficult to you to define these 2 terms. So let me give you the answers. And if you compare to what you have suggested and find that it doesn't match, you can go back in what we have covered, what we have written in the summaries. So an element is a type of matter that is composed by atoms of the same kind. And when we say atoms of the same kind, we mean atoms which have the same atomic number. Remember, we said that the atomic number is like the ID of a given atom. It's like the DNA of a given atom. So atoms which belong to the same element should always have the same atomic number. And a substance composed by atoms of the same atomic number form what we call an element. And what is a compound? A compound is defined as a pure substance made up of 2 or more elements which are chemically combined. You can have one atom and another atom which have different atomic numbers and get them combined. For example, if we write the molecular formula of water, we find that there is hydrogen and oxygen. So in this case, we have a compound. And what is a compound? We said that it is a chemical combination of 2 or more atoms which come from different elements. Now, let us have a look at why atoms combine. Because what we are saying now is the combination of atoms. Why do you think these atoms combine? Think about it, and I will tell you why the atoms combine to let you compare what you have suggested with the right answer. Okay, let's go on. So before we explain why atoms combine, let us define what a radical is, because today's lesson is the radicals. So what is a radical? A radical is a group of chemically combined atoms that behave as if they are a single ion in a reaction, or as if they form a single particle in a reaction. So when a reaction is taking place, and what do we mean by a reaction? It is a chemical change. We know the physical changes and the chemical changes. And the difference between a physical change is that the nature of matter is not changed for a physical change. But with a chemical change, we produce new substances, which are totally different from the substances we started with. So in a chemical reaction, which involves a chemical change, when you combine atoms, you produce new substances. When you make substances react or combine in various ways, you produce new substances. So when you have a particle which is composed, I can call it a polyatomic particle, which is composed by many atoms, but which behaves as if it is a single particle in a reaction, and which particle contains or has a charge, we call that one a radical. A radical is a group of chemically combined atoms that behave as a single particle in a chemical reaction. And you should always remember that these radicals, they have charges. They may be positively charged or negatively charged. When we will be on the next slide, we will explain the difference between a radical and a normal ion. An ion which is defined as a charged atom. Now, what do we get when radicals combine? We know compounds. And compounds are formed by radicals. So when you take one radical which has a positive charge and another radical which has a negative charge, you can combine them and produce a compound. I think it is very clear. So, after seeing that, compounds can be formed by combining radicals, and now we understand and know what a radical is. Let us have a look at why these radicals form. Why do radicals form? And to help you understand why radicals form, I have a question to ask you. Something you have to think about. And then we analyze it. You know that in our society, in a community, we have employers and employees. You know what it means. A boss and someone working for the boss. Employers and employees. And we know that both the employers and the employees, they need each other. Why do they need each other? Why should we have employers and employees at the same time in a given company? You think about it. Why is it like that? And how is it related with the formation of compounds or radicals? Think about it, please. I give you some seconds. Let us find the answer on the next slide. We know that people have different abilities, different skills, different competencies. And because of that, there is no one who can do everything. But everyone can do something. So we are there to help each other, to complement each other. What a boss can do, maybe the employee cannot do that. And what the employee can do, maybe the boss cannot do that. So they need each other to help each other and live in a stable community. What you want, you can get it from your boss, and what the boss wants can get it from you if you are the employee. You can also think about your first day when you were at school, when you went to school for the first day. How did you feel when you saw others with their friends? Immediately you had a wish of having a friend, isn't it? Everyone is like that. So in a community, we need friends. And how do you feel when you don't have that friend? Somehow you feel like you have to keep on searching for a friend. And when you get one, you feel happy. In some words, we can say that you become stable. And it is the same, if I can say, with the atoms. Atoms will always be stable, more stable, in the combined form. So when they combine with other atoms, they become more stable than when they are isolated. And that is the reason why radicals form. The reason why atoms can combine to form radicals. It is the same reason why atoms can combine to form compounds or molecules. And here we have the examples of some common radicals. We have a sulfate radical, which is SO4. Sulfate, which is SO4 2 negative. This S means that we have one atom of sulfur and 4 atoms of oxygen. And the 2 negative here, it is the charge of our radical. We also have the carbonate radical, which is composed by 1 carbon atom, 3 oxygen atoms, and which has a charge of 2 negative. There is a sulfite ion, 1 sulfur and 3 oxygen atoms, hydroxyl with 1 oxygen and 1 hydrogen with a single negative charge, the hydrogen carbonate which comes from the carbonate ion. If you add a hydrogen on the carbonate ion, you get a hydrogen carbonate. And in this one, we have 1 hydrogen, 1 carbon, and 3 oxygen atoms. We have a phosphate radical with 1 phosphorus, 4 oxygen atoms, and a charge of 3 negative. There is a nitrate radical, which is NO3 negative, hydrogen sulfate, which is derived from the sulfate radical by adding a hydrogen to the sulfate radical, and we get 1 hydrogen, 1 sulfur, and 4 oxygen atoms with a single negative charge. So these are some of the common radicals. But here, what I can tell you is that I have not exhausted the list. So we have more examples, and more examples can be seen here on this slide. So we have a sulfite ion, we have a phosphite ion. So you can see that when we have 4 oxygen atoms, the name ends with ATE. But when we have 3 oxygen atoms, the name ends with ITE. So the difference is on I and on A. So if I have SO42 negative, here we have 4 oxygen atoms, then it will, because of the sulfur, it will be the sulfate. Sulfate, you see the A, and when it will be 3, what do we get? We get sulfite. Sulfite. And here it is for phosphorus with 4 oxygen atoms and phosphorus with 3 oxygen atoms. Can you please suggest the names? The names, please. All right. So here it is the phos and phos from phosphorus. And what do we add here? It is ATE because of having 4. And here we add ITE because we have 3 oxygen atoms. And another radical we have here, it is the ammonium ion, a positive radical. The ammonium, NH4, so we have 1 nitrogen, 4 hydrogen atoms, and the whole particle has a charge of 1. We also have the nitrite ion, and for nitrite, when they contain nitrogen, if it is 3 oxygen atoms, like here, NO3, 1 negative, we use, it will be nitrate, ATE, and when it is 2, it becomes nitrite. Okay? The nitrate. And every time, if you consider, for example, this phosphite, if you add a hydrogen to become like this, then the charge reduces by 1. So we get 2 negative from the 3 negative we had here. If we use it on this one, the phosphate, it will also be 2 negative, like this, HPO42 negative. And then in front of the phosphate, you add hydrogen. Hydrogen phosphate or hydrogen phosphate. If it is a carbonate ion and you add hydrogen, it becomes hydrogen carbonate. And always the charge reduces by 1. Now let us have a look at the charged atoms. We have seen that atoms can combine to give charged particles which behave like a single particle, and we have called those ones radicals. But what is the name when they don't form radicals? When the atoms become negatively charged or positively charged, but do not give us what? Do not give us a polyatomic particle. We call those ones ions. And to differentiate it from, or to differentiate them from monoatomic ions, the radicals, we call them monoatomic ions. and the radicals are called polyatomic ions. So radicals too are ions. But in this case, we have two types of ions. So sometimes atoms can become charged without forming a group of atoms like radicals. Then they form monoatomic ions. We will see the examples. And we know two types of charged atoms. We know positive and negative particles, and the positive are called cations, and the negative are called anions. And when they combine, we get compounds, just like the radicals. And what we have to note here is that radicals are also ions, but which are polyatomic. So they contain many different ions or atoms. And we need to know these ions, the monoatomic or polyatomic, because if we have to write the names of compounds, then we need to know the different parts forming those compounds and their names, of course. If we want to write the symbols or the molecular formula of compounds, we need to know the parts forming those compounds. So that is the reason why we have to learn this. And here there is an example. What I'm using here is a piece of chalk. And the main chemical component of a chalk is a substance we call calcium carbonate. It's this one, calcium carbonate. And you can see it is composed by two parts. So this is a monoatomic ion, and this is polyatomic ion, or the radical. You remember the carbonate ion. So when you take a monoatomic and a polyatomic, it's possible to make a compound. And from here, we can deduce the name. This is calcium, and this is the carbonate. So the compound is calcium carbonate. So we need to learn this to know how to name compounds or write their molecular formula. Here we have some examples of monoatomic ions. Sodium 1 positive, and the name is sodium. We have oxygen 2 negative, and the name is oxide. Here we have the chloride, and from the oxide and chloride, you can see that the suffix there is IDE. So on nitrogen, it will be nitride. Nitride like this. Nitride. And here we have iron 2. Iron 2. And here we have iron 3. And how do we name this one? The iron 3 will be named as iron, but because it has a charge of 3, then we put 3 there. So to distinguish these two ions, which are both charged, we use the charge. And here we have copper 1 and copper 2 plus and sulfur 2 negative, and I leave this as your exercise. You will do that as an exercise, okay? You will try that. On the next slide, we have an exercise. Name these radicals or monoatomic ions. We have them there. And write the formula of these particles: ammonium, iron 2, the phosphide ion, hydrogen carbonate, and the sulfate. Try them, please. You have 1 minute just to help you recall what we have been discussing. And let me remind you this: it is always better to use your phone. If you have a smartphone, you can take a picture of these exercises so that you can keep them. You know, the time is very short, so it's better if you use that technique and keep everything. And here we have the answers. We have the bromide ion. This is the bromide ion, as it can be seen on the answer. And this one is the cation of aluminium, hydrogen phosphate. And this is lead 2+, because the charge is 2+, but because we have another one with 4+, then we use 2 here, and in the bracket we use 4. You have to remember that when we have to use these numbers, we always write them in the Roman form. And number 2, writing the formula of the particles, here we have ammonium. The ammonium ion is this one, or the radical. Iron 2, it's this one. We have seen it in the previous slides. And the phosphide ion, of course, will be phosphorus with the 3 negative. We will explain later why we have these 3 negatives, these charges. The hydrogen carbonate is this one, and the sulfate is this one, the last one, which is the sulfate. Now, let us have a look at the homework you have to try when you will get time. I know you are so courageous, so you will manage to get time and work it out. Why do radicals and compounds form? Why do radicals and compounds form? We have seen this. Number 2, name these particles. K1+, N3 negative, SO3 2 negative, Cl1 negative, and NO2 1 negative. And the last question, but of course not the least, write the formula of a fluoride ion, a carbonate radical or ion, of course it will be polyatomic, phosphate ion or radical, the oxide, and finally the hydrogen sulfate. So note them down, please. Hurry up. The time is running too fast. And as we are close to the end of this lesson, let me thank you very much for your participation, your attention, and for always being there to follow these programs. Thank you very much. See you next time.